Alright, so naturally, as I was about to start this video, my stir plate broke down, so we're going to have to do this one the old-fashioned way. That's fine, we'll make do for now. So the first compound that we're going to be making is ammonium uranyl carbonate. I figured that it would be a useful form to keep this stuff in. Solutions of uranyl nitrate are not stable over long periods of time, from what I understand. But ammonium uranyl carbonate is stable for being stored, from what I've read, and it's very convenient because, I mean, depending on what you react it with, you can either remove the ammonium ion or the carbonate ion as a gas and replace it with something else. So it's a very versatile form of it. We are also going to use the supernatant solution of it in order to make another compound. But we'll get to that later. So we're going to get 2 for the price of 1 out of this. So this amount of solution has the equivalent, it has 3 grams of uranyl nitrate dissolved in it. So the first step of the synthesis is to add ammonia to this to precipitate the uranyl ion as ammonium diuranate. I am just going to be adding some concentrated ammonia, drop-wise. How am I going to stir this and have the camera catch it and not have it sucked back into there? Well, tell you what, I'm going to have to move you guys over here a little bit and just zoom in. Look at that nice little, layer of yellow cake floating on there. Isn't that nice? Get a little bit more ammonia. Let's give it a stir. Add some more. Okay. Now we know that there's excess nitric acid in here, so yeah. It looks like we're going to having to neutralize it with the ammonia before we're going to make any progress. Otherwise, the nitric acid in solution is just going to redissolve it. Although, it's interesting to know that that's what it will do, and now we know that. Oh, I think we've hit that point. Fantastic. Let's add a little bit more just to be on the safe side, just to make sure. There's more still precipitating out. Oh yeah, we still got more to go, I think. Yep. Oh, wow. Oh, shit. Sorry about that. It's a little cumbersome trying to reach over here and put this stuff in here and stir it. Sorry, I'll adjust as I go on here. Bear with me. Okay, so we'll know we're done when the yellow color from the uranyl ion is completely gone. So what I'm going to do now is let this settle out here. It should be very insoluble in water, so we should be good. And that way, once it's settled out, we can take a look at the solution, add a little more ammonia to it, and see if we need to keep going or if we're done. Alright everyone, it is the next day, and this is our ammonium diuranate. I have diluted it down, well, not diluted it, but I'll tell you what I did here. I basically just added water to this and got the volume up to about 100 mils. I would let it settle out, and then using a pipette, I decanted all of the water into a beaker. Did that several times to remove as much of the ammonium nitrate as possible. So I think, I mean, I don't know, the volume's down to about 30 mils. I think we're going to be okay. I'm hoping that this is not too dilute. After the fiasco that was the hydroxylamine potassiouranate, even though that ultimately worked, still, I would prefer not to, end up requiring some massive volume of liquid in order for this to be done. I do have a bigger beaker on hand, just in case it is required. So, let me bring you back up here. I know, we're so professional here, right? Such high production values at the poor man's chemist. God, I need a new tripod at some point. This thing's such a piece of shit. Okay, so our next step has to be done at 70 degrees C. The way the textbook reads, we need to combine a concentrated solution of ammonium carbonate with this in a hot water bath at 70 degrees C. Now, this is distilled water, and I've got it in the evaporating dish here because I'm going to use some of this 70 degrees C water in order to dissolve the ammonium carbonate. Then I'm going to add, this is 6 grams of it, and I'm going to add that into here, put it in there, and stir it up real good, and we're supposed to leave it in there for about 10 minutes. I mean, if we need more ammonium carbonate, I've got it here just in case that's not enough. I am as prepared as I can possibly be, I think. So, let's give it a shot. Will you please fucking dissolve? Stop being such a filthy, dirty whore. Thank you. There. Alright. A big moment here. Okay. I am now going to combine this, and hope to fucking hell that it dissolves. Now, ammonium carbonate is in excess here. Oh, okay. It's happening. Yeah, I just wanted to triple check. The textbook says just with an excess of concentrated ammonium carbonate. But I think that did it. Awesome. Okay. I'm going to go ahead and put this in a water bath here. Bring you guys in where you can see shit. Come on, you piece of shit, stand up. People can fucking see things. There we go. And okay, our temperature is good. 68 degrees, but I think we're okay. Timer. 10 minutes. 10 minutes. Come on. Alright, there we go. Oh, look. It is very transparent now. So, apparently that was enough. Excellent. Alright, I will come back when we're ready to go on to the next step. Okay, that's 10 minutes. Our water bath never did quite hit 70. It didn't drop below 66, but I couldn't ever get it right up to 70. But we're going to follow the instructions exactly. So this is what we've got. At first, I thought something may have started crystallizing out. Within 4 minutes of putting it in the water bath, it started, well, maybe something did crystallize out. Alright. I don't know. It said that our product was supposed to take a lot longer than that. And it was definitely clear there when we started. Maybe this is some of our product that has already precipitated out a solution. I'm going to let it cool off here and we will see what we get. Well, everybody, this is the solid residue that was left over. It is a really bright yellow. I mean, like, really bright. I don't know, man. That, to me, just does not look like the color of the ammonium diuranate. That, to me, just looks like it is a much brighter yellow. But, whatever. Alright, the next compound that we are going to synthesize comes from atomistry, and it is hydroxylamine potassiouranate. Now, we just saw with the first compound that we did that there is excess nitric acid in the uranyl nitrate. It's not really surprising. It is really hard to tell, going by what it says on atomistry, if it matters, like the order that things are added together. The way it reads is it wants you to combine the uranyl nitrate with the hydroxylamine and then add in 10% potassium hydroxide and then leave it, and the compound will crystallize out of the solution, which is why I try to keep the volumes very small. But, I mean, I'm not really sure how hydroxylamine is going to react with nitric acid that is still going to be that strong. You know, I went and I looked online, and from what I saw, it broke down into nitrogen oxides, which is a little counterproductive. So what I'm going to try is adding a little bit of this KOH to the uranyl nitrate solution first. This is our hydroxylamine solution. It's just clear. There's nothing to see there. So precipitate first formed is redissolved. I think. No. Oh, okay, I see. It wants us to keep adding it until the precipitate is redissolved. Alright. Okay, so things weren't working out the way they were supposed to, so I tried the time-honored chemist tradition of just add shit in wild excess until something happens. And that's basically what I did. I mean, we added plenty of potassium hydroxide. That gave us a solution of potassium diuranate. So, I mean, the stoichiometric amount of hydroxylamine wasn't cutting it, so basically I just started putting hydroxylamine in there and stirring until the precipitate dissolved. So, now what we've got matches what, you know, this sort of atomistry article said that we should get. Now we just have to leave this, and, yeah, crystals of our product should form over time. It probably will take it a little while. If we don't start getting crystals, I mean, I don't know. I highly suspect that we will here soon. So I am going to leave this to sit undisturbed, where hopefully crystals of our product will begin to precipitate out. But here is our other experiment. the hydroxylamine potassiouranate. Now, from what I can tell, this was successful. It is supposed to be a reddish-yellow compound, and that right there we go. It is a reddish-yellow compound. That looks like it crystallized out onto the walls of the evaporating dish last night, so very, very cool. God, look at that. Isn't that fucking awesome? Alright, everybody, we're going to take a look at another type of uranyl compounds, but these are peruranates. Basically, instead of UO2, it is UO4. This is a little bit of ammonium peruranate that I made, going by the method that was on atomistry.com. It's very hard to tell these things apart. They all kind of look yellowish. But I only made a small amount of it. This was kind of my test just to make sure that this was actually going to work. What we're going to do here is something a little different. We are going to go for ammonium uranocarbonate. This is a little bit of our ammonium uranocarbonate solution. The first thing that we're going to do is we are going to add some hydrogen peroxide to it. Add some hydrogen peroxide, and you see that we get an immediate color change to this lovely orangish red compound. Now, atomistry doesn't say what color it is supposed to be, but I have no reason to doubt that this isn't it. One thing that seems to be a running theme with these peruranates is that you have to add alcohol to get them to precipitate out. Interestingly, sodium is the only one that it says doesn't require alcohol, which that's a little different. And sodium peruranate will crystallize out in yellow needles. Now, sodium or potassium peruranate is supposed to be more of a reddish compound, but it can't be made in the way that we're doing. So there's a little bit of ethanol. And come on there, you. Doesn't look very different from the other one, does it? It's interesting that the solution has kind of changed color. Fascinating. Alright, everyone, this video is already getting really long, so I am going to go ahead and stop this here. We got to see all of the compounds I wanted to do except for two of them. One because I just couldn't get it to work, which was thallium uranocarbonate. I'm not really sure why. I am working on, I think that the problem lies with my thallium salts, so I'm working on those, and hopefully I will have some ready to go here with that in the near future where we can try to give that one a try. The other one was the uranyl hypophosphite, and the only reason I had to pass on that one is because there's just too much nitric acid left over in it, and uranyl hypophosphite won't precipitate out in acid, so rather than waste the solution trying, just need to figure something else out. As you can see, I only used half of my uranyl nitrate solution. I'm not really sure. There are several other compounds I can make. I really need to deal with the problem of this excess acid, which I will probably do by precipitating all of this out as ammonium diuranate, and then, filtering it and washing it thoroughly, and cleaning it up that way. And I may look into trying to convert it into another uranyl salt, and something that's a bit more amenable to being turned into other things I'll look into some uranyl sulfate or something. I don't know. I need to do some more reading. But anyway, if you've enjoyed what I've done with this video, give it a thumbs up. If you didn't like it, give it a thumbs down so I know you didn't like this kind of stuff. Subscribe, comment, share the video, and until the next one, y'all, I will see you later. Oh, and to forestall the question of anybody asking me where all the waste went, it's all right here. It looks like most of it is present as some kind of yellow cake. I'm just going to dissolve it all with nitric acid here at some point and then reprecipitate it out as a pure diuranate. So it's very easy to process. So anyway, sorry about that. I mean it this time. I'll see you later in the next video, y'all. Thanks for watching.